Good evening, sir.
Thank you, bro.
Yes, sir. I'm still waiting for the rest to join us, sir.
Okay. I don't know how you will do my case, so
Ẹ máa ní láti create time ni o.
sir.
Mo ní ẹ máa ní láti create time ni o. Àìjẹ́ bẹ́ẹ̀ the whole thing will just be a waste.
That's true.
Bó jẹ́ 30 minutes per day.
Hmm. But you know, those questions you are setting for us, that's not the approach you use for the lesson.
Ṣé initially bá?
And you know, normally you should give a real life question. Why you use that real life question to teach us? You know, generally you just teach us, and then someone like me, when I see that real life question, I'll be like, you'll take any approach for this thing. But I think that is not really the big thing. I think the big thing is because I've not been practicing.
Okay. The reason why I make it a little bit, I was thinking it's very, very easy for us uh, to relate with tó bá jẹ́, but it's not complex, it's just application of if statement. Tí wọ́n á ti kàn lè
Okay.
understand the concept there, it's just apply it. But for the assignment,
Okay.
I already have a plan that I just want everybody to attempt it. Then those I can still correct.
Attempt it.
I was planning to prepare a video on an explanation on it, but I just want everybody to have that attempt first on it.
Okay.
So by this 8:21 now, no, I about seven in the class. I want to put it on the group now. If I wait till late 13, I don't say what I'm actually sacrificing the only battery. Where I am now, there's no always light like before.
Okay, that's true.
So the battery by ti lọ báyìí, it's only my phone I can use to do anything productive till the day breaks. Àfi tán bá tún múná wá. Báwo ni dé sir?
Thank God though. It went well. Do you know if daddy is back?
Yes,
If not
wọ́n
padà.
ti délé ni.
Okay. Èmi ló yẹ kí n drive wọn tẹ́lẹ̀. But my license,
Ó ti expire.
mi ò tiẹ̀ tí gbà ní.
Àwọn fúnra wọn náà wá drive lọ́kàn. Àwọn àti mọ́mì
Yes.
tẹ̀lé wọn lọ.
Ẹ̀mọ́ mi tẹ̀lé wọn lọ, but ó dàbí pé ẹnìkan náà bá wọn lọ mi mẹ́tò.
The media person in charge of camera.
Okay. Program wo náà lọ fún?
Wọ́n lọ mínísítà ní Camp Young ní Ẹdẹ. So I think they are ministers also, not all ministers. So he was invited to come and minister.
Okay.
We are welcome to tonight. How was our day?
Fine, sir.
So thank you for coming late. So we start right away. Thank God we are up to 4. Okay, so tonight we'll be doing a revision on function, and it's going to be interesting. I promise us. So tonight I'll be making use of Visual Studio Code as my IDE to take the class, and over time we've used all manner of IDEs, and I believe we are getting familiar um, with the fact that we don't have to stick with a particular IDE in running our program. So I'll be sharing my screen right away. Okay. Can we all see my screen?
Yes, sir.
Okay, sir. So the concept behind function is um, it's a, should I call it a technique that is being adopted to attend to some issues in programming, like the issues of repetition. Imagine if I want to print, take for example, I'm writing a program that add, let's say, two numbers together, and it's not only that program that I will write for everything. Maybe I will need to add two numbers for about 12 times in all of my code. Now, will I need to be will I need to be running that particular exercise and repeating it for those 12 times? That would be very, very tedious. And we came up with the concept of function, that instead of having to be repeating, let's say, 6 lines of code like 12 times, why don't we just create more like a function, more like a package that anytime we need to run that particular set of instruction, we don't need to repeat those 6 lines of instructions again. We can just call function. So they came up with the concept of function. So a function has a name. That's the first thing. A function has a name. A function has argument. A function has argument, and some function returns values, and while some don't return value. All these are theory. We'll get to start coding right away. On my screen, for some of us, I think it's my first time of using this is my first time of using VS Code for our class. And underneath there, you see the tab, problem, output, and terminal. So anything I run at the upper section here, when I run it, I see my output at the terminal section. And so let's start. So this is how we write a function. What I said may not be too practical to some of us yet, until we start playing with quite number of things, begin to see the effect. But there is a syntax for writing a function, and the syntax is you start with the keyword called def. Start with the keyword def, then a function should have a name, because you call a function using the name that you assign to it. So if and let me say I give it the same principle that applies to naming variable, is the same rules that apply to naming a function. You don't start with a number. If there's need to separate words, you use underscore. You don't use special character, and so many. So let me call this function let me call it name splitter now. Name splitter. And the example I want to run with us is a case that you have someone enter his full name and you want to split that name. You want to split it into maybe middle name, last name, and first name. So we are going to be running that now, and I'll be explaining things as we go on. So okay. So now, when this is the name of this function is called name splitter, and as you can see, there's a parenthesis. This is called a parenthesis. There's a parenthesis in front of it. Now, there are times that this parenthesis will be empty, and there are times that it will carry value. So it varies. So I think let me start on this note. Let me just say, let me create the function called um, greeter. The name of the function is greeter. So this function greets people. So, and what it does is it just print hello, how are you? Hello, how are you? Now, that's what this function does now. Now, the concept behind function is if I need to print hello, how are you about 20 times, I don't need to be saying print hello, how are you, print hello, how are you. No. If I just need to run that particular set of code anywhere I need it, all I just need to do is just call this function using the name. So in this case now, the name of my function is greeter, so I'll just call it greeter. So now, as you can see, def, the name of the function, then there's a parenthesis. So in this case now, inside the parenthesis, there should be argument, but in this case, there is no argument. So there are functions that has arguments and there are functions that don't have arguments. So this particular function now only executes, but it does not have argument. And outside the function, to make use of the function now, I need to call the function using the name of the function. So let me run this now, and let's see what we have at our output. As you can see here, our output, hello, how are you? We have that as our output. Now, if I need to do hello, how are you 20 times, all I just need to do is call the function again. I need to call the function again, and if I run this, you can see I have it twice. And let's say if I need to, maybe if it's 20 times now, I can as well use our for loop, which we are familiar with. Let's do for a in, let's say, in range 1 comma 20. Okay, let me go from 0 comma 20. Then I can call the function. So if I say greeter, I can call the function inside my loop. If I call it, you realize that it will call this function 20 times, and we have 20 hello, how are you? So as you can see, we have 20 hello, how are you? So the concept behind function is you have some set of codes you want to execute, and you know that you will need to maybe call them subsequently as you program on. Then in that case, you need to create a function. And I said that there are two major types of function according to me. There are some functions that there are functions that just execute, and there are functions that return values. So let's dive in much more. So that was an example of a function that does not have an argument, a function that does not return anything, and a function that only executes. So there are functions that they execute, there are functions that they take in argument. So let's dive in deeper into something very practical. Imagine we have a function that gives us the square root of whatever we pass into it. So in this case now, we'll be passing in argument. So let me create a function called square rooter. Square rooter. Now, this particular function, we need to take in an argument. So the argument will be what will be sitting in that parenthesis. So I can call the argument um, var, which can first, so that's the, so it's just like the name of a variable. So the val now is the name of the argument. Now you can have as many arguments in a function. So what this function does is it prints val raised to power 2. That's what it does. Now I've created that function. Now if you take note, anything that is inside the function is being indented, and I believe we are familiar with indentation when it comes to Python now. So for me to make use of this function now, this function has a name called square rooter, and it takes in an argument called var. So for me to be able to make use of this function called square rooter, I need to supply the argument now as a parameter. That means I want to tell it what var is. Let's see an application. If I want to make use of this function now, I'll just call it square rooter bracket. Now the first one we did the other time, all we did was that we just called greeter. We didn't pass anything inside of it. But in this case now, the function we've created an argument that, okay, an argument needs to be passed, and that will make it more dynamic. So now, as you can see, when I wrote square rooter, it underlined it as red because it's expecting me to pass in a parameter. So when you are passing in a value, when you are calling a function, it's being referred to as a parameter, while inside the function, like as we have in this case, val is being referred to as an argument. So maybe if I want to find the square root of 4, I will just pass 4. So what happened is, when I call this, all I'm doing in this line here is that I'm calling this function called square rooter. When I'm calling this function, I need to pass in what I want to replace var, like what should be sitting in the position of var. So that's the implication. So 4 will be represented, the var will be representing 4 inside the function. And when I'm saying print var star star 2, which is var raised to power 2, that means I'm saying 4 raised to power 2. So if I run this now, so as you can see here, our output to be 16. Our output to be 16. So that is just an instance. So I would like to welcome question at this point before we move on to other ways of playing around functions. So is there any question so far?
None for me, sir.
Okay, sir. Any questions, sir? Please, let's ask our questions now so that we can move on. We still have a long way to go.
No, sir.
Okay, sir. Bro, okay, any question? Bro, do you have any question?
Yes, I have a question.
Okay, sir.
Why didn't you print? Okay. I've seen the print already.
Okay, sir.
Yeah.
Now, okay, we'll be continuing now. Now, inside the function, I only use the word print because that's one of the simplest form. But we can have like chunks of code inside a function. We will be doing all manner of complex things. Like we'll be doing some example as we move on. We'll be doing them, maybe doing them inside the function. It will be a very complex, and that's the beauty of a function. Maybe you have one complex algorithm that you want to subject some set of values to, and that particular algorithm, you need to implement it about 10 times in your main code. So will one have to be rewriting the algorithm? No, one just need to create a function, put the algorithm, and anytime one can make a call to the function. So now I've made an example of a function that does not have any argument, like the one I created here, greeter. And I've created another instance of a function that has argument. In this case now, the argument is referred to as var. So you can give it any name, but just know that the rule is the number of the argument. Now, when you have an argument, the number must tally with the argument that you have here. Let's me create another example now. Let's say we want to create a function that adds two numbers together. A function that adds two numbers together. So let me do that. Okay, so I'm trying to comment those lines out. So let me create a function that adds two lines together. So I'll call it I'll call it value adder. Now, this function adds two values together. That means I will need to pass in two arguments. So I can call my first argument x, and I can call my second argument y. So don't forget the full column concept. So what this function does is it prints s plus y. It prints s plus y. Now, for me to make use of this function, I must pass in two arguments. So if I want to add any number, add two numbers now, I will do value adder, which is the name of the function. Then if I say 7,9, that's when I'm correct. What this means is that s will come and represent y, represent 7, y will come and represent 9, and it adds the two together and it prints it out. Now, maybe later on I need to add 10 and 20. I don't need to rewrite and do all that. I just need to call my function and say 10, 20. So I'll just be making use of that using the name of the function. So let's run this now. Let's see what we have. So as you can see, the first case is did this, the second case is did this easily, having not to repeat chunk of code. Now that is just another instance. Now it's not only single value we can pass into a function. It's not only single value. What I mean is, now the first instance I did, I passed in an integer. Second instance I did, although we have two arguments, I passed in two integers. I passed in two integers. So, but I can actually pass in other data types. Imagine I have a list of like we've always done, we've always been doing. We have a list of favorite food, and it's a list, and it's yam, beans, um, potato. Now I will do something very funny. So now I have that list of food. Let me add another one as bread. Now I have, like, it's not strange to us that far food is a variable like every other variable, just like the way I will equate s equals 5. I've only equated far food to be a list. So now take for example, I want to create a function that just returns that just print only those that start with b. So I can just create a function here. Let me do that. So I create a function def, and I call it b printer. Let me give it that name, although it's quite ridiculous. B printer. Now let me call it list b list printer. Okay, let me leave it b printer. So now I need to pass in a list. I can call this one list. Now list involved. So that is the name of my argument. I can give it any name. Now what I want to do is I can create a complex algorithm inside this function. I can just we've always done, I can do for each var in for each var in the list now, in the list involved. Now, if, which we are familiar with, if each var, if the first element, if is equal to b, then what should be done? Print each var. Now, I will explain this now. Now, this is a function, and this is a chunk of code that needs to be executed. Now, the list involved is actually a list, but it's coming in as a single, it's a variable like every other variable. But what we are doing inside our function is what we have between line 23 and line 25. I'm iterating over the list, and I'm only printing elements in the list that start with B. That's what I did here. If each var. We understand the concept that when I do a for maybe anything like we've done, yes, we did last week, I iterate using a for loop. You can either iterate over a range of value, or you're iterating over a list of value. You can as well iterate over a dictionary. So in this case now, we are iterating over a list. So when we are picking each value, each element in the list, if the first character is B, and if that's the case, print that particular element. Now, we've already created a function. If I run this code, you won't see anything. That's it. Now, we've already created a function. It's just like when you create a concept, you don't make use of it. So the only way to make use of this is to call the function. And so I want to call this function. I'll call it using the name, like I said, bprinter. Now, bprinter needs an argument. And the way it has been written, it has been written to take in uh, to take in an iterating variable. So in this case now, I already have a list called favoo, so I can just pass fav food. So what happen is list involved will take over whatever I've passed in as far food, and it will execute all what we have here. So when I run this now, so as you can see, it's printed out only bread and beans, only bread and beans. So this is, so imagine now, maybe I have another list now. Maybe I have another list of five sports. So I have five sports. I have basketball. I have baseball. I have hockey. I have football. So now I want to get the sport with I want to only print sports that only start with B. Now, normally I would have come and rewrite these three lines of code again. And that's the beauty of function. I don't need to rewrite it for five spot now. All I just need to do is call the function, which is bprinter, and I will pass in the list I want to work with. In this case now, I have five spots, five spots. So now, if I run this now, you can see it first printed out the one for the favorite food, and printed out later the one for sport. So it just makes life so easy. So it's just a line, just a single line. I've been able to execute three lines of code. That's the beauty of function. So I would like to welcome questions at this point. If there's any question before we move on. Any question?
No, sir.
Oh, okay, sir. So We move on now to um, the other way a function may take. Now, you may have a function that don't only execute some set of instruction, but rather they return value. They return value. Now, let's play with something very familiar. Now let me create a function. So let me just comment out what we just did. Okay. So create a function. I create a function. Now, another way to create a function is when you create a function that returns a value. Does not only execute some set of instructions, it returns a value. So now imagine I want to create a function that returns the square. It does not print it itself, but returns it. And the significance of returning is when it returns a value, I may want to use the value return to run some further executions. So now let me create a function called square router. I will create a function called square router also. Then maybe the person passing a value called s now. Now, instead of printing the square root of s here, I can decide to return, and we use the keyword called return. So I have return. What do I want to return? I want to return s squared. I want to return s squared. So now, when you have a function that is returning a value, now when you are calling it, now if you take note, when we're calling those functions, we just call them immediately by their name. Now, but when you have a function that is returning something, whatever is returning, you need to cache it. You need to cache it somewhere. So now I can, if I want to call this function, normally initially I would have said square rooter and I would have passed maybe 4 in my case now. But when I do that, since this is returning a value, I need to cache the value is returning somewhere. So I can say my answer equals, so that's the way to cache it, because when you call this function now, it's returning something, so you need to cache it somewhere. So it will return, now I'm passing 4, it will 4 will replace s, it will be 4 raised to the power 2, which is 16, so it will be returning 16. So when it's returning 16, where do I want to cache it? So it will return it here, and the 16 now will now be stored inside answer. So maybe I want to work, I still want to do some further things with answer. Maybe I still want to do some other manipulation with whatever value is being returned. I can go ahead and still do. And maybe if it's I want to print the answer inside my main program, I can go ahead and do the same also. So this is a function that returns a value. So let me run this now and let's see our output. So we can see it printed it out. Now I can decide not to print it. If I remove the print statement and I just run it, you won't see anything, but it has actually executed the function, but it has stored the function inside the variable called answer. So those are the various ways you will always see a function. A function will always take that format. To always take that format. So our time is almost up. So I want to welcome question for the next 10 minutes. Any question? Mr. Stephen Bro, should you any questions asked?
No questions, sir.
Okay. Are you sure, Mr. Stephen? No question?
Yes, sir. Yes, sir. Understood everything, sir.
Okay. Bro, should you any questions, sir?
No, sir.
Okay, sir. So now what I want to do is I will end the class here, then I will send a particular link for us to read up a material. It's going to be a link, a page, it's a web page. So I want us to look at the examples there and the various things that were said concerning function. So if we are seeing anything strange there, I want us to raise questions on the page. So, but I want us to immediately after I'm ending this class now to go and do that. So, assignment on function will be coming in later in the week, but I want us to immediately go and read on functions now so that when we begin to see various examples on many of the things I've said tonight, um, we'll be able to understand. So that's the best way to learn. If you postpone and say we will study it later, everything will look like magic. So I'll be sending the link very soon. So I don't know if there's any question before I end the class for today. No
No,
question.
sir. No
Okay.
question.
Okay, so all our revisions will be ending this week. So by God's grace, next week we'll go back to our syllabus. So the revision we've done for the last 2 weeks is based on the demand of some students in the class. So thank you so much for today.